Hello everyone, today we'll study the rebound hammer test. The rebound hammer test is used for assessing the likely compressive strength of concrete, assessing the uniformity of concrete, assessing the quality of concrete, and assessing the quality of one element of concrete in relation to the another element. So this is the rebound hammer. In this, the different parts of rebound hammer you can see here. This is a plunger. Behind plunger there is impact spring. Behind impact spring there is a hammer mass, and this is a locking button, and this is the window and scale for measuring the rebound index, that is rebound number. So this graph which is showing that is rebound number versus the compressive strength of concrete. So this is the grinding stone, that is abrasive stone. If the surface of the concrete is rough, in that case we have to apply this stone for making the surface smooth. So here you can see the different position of rebound hammer, how to hold the rebound hammer. This is the 0 degree position, and this is minus 90 degree position, and this is plus 90 degree position, that is plunger is pointed toward downward direction. Now how to apply the abrasive stone on this concrete surface, you can see here. Before starting the rebound hammer test, we have to make the surface smooth by using the abrasive stone. Now draw the grid or boxes. Take minimum 6 readings and maximum up to 20 readings for single point. Generally we are taking 10 readings for single point. Select minimum 150 mm diameter area of structure for the test. So you can see here total 24 grid boxes I have drawn. Now mark the impact points and give it numbering tentatively. So I am considering total 10 impact points. So the point of impact should be at least 20 mm away from the edge or shape of the discontinuity. You can see here now from shape of the discontinuity or edge of the any structural element, the impact point should be at a distance 20 mm minimum. You can take 50 mm also. The distance between 2 points of impact point should be 20 mm minimum, and the diameter for the impact area should be 150 mm. You can see the distance between two impact point is 20 mm, minimum distance according to IS code, and from the edge or shape of discontinuity the distance is 20 mm. Now we have to start the process. Now we have to set the plunger against the surface of the concrete. Now after setting it, you will hear one sound. After that, press the locking knob, and after pressing the locking knob you have to measure the reading on this scale. So you will see here the reading is 40, that is rebound number, rebound index is 40. The red line indicates the reading, that is 40. Now we have to note this reading in the record book, that is for point number 1 rebound number was 40. Now again simultaneously for second point we have to follow the same process. You can see here the rebound number is 41. It is 39. Now again note this simultaneously point number 3, point number 4, point number 5 up to point number 10 we have to perform the similar process, and we have to note down the readings, that is rebound number, in the record book. Now you can see this graph, that is rebound number versus compressive strength of concrete. So here are the three lines mentioned on the graph. The middle line indicates the 0 degree position, bottom line indicates the upward, that is minus 90 degree position, and upper line indicates the plus 90 degree position. That is, if the plunger is pointed toward downward direction, consider plus 90 degree angle. If it is pointed towards upward direction, consider minus 90 degree angle. And if plunger is horizontal, in that case consider 0 degree angle. Now we have to take the average value of rebound number. So the total 10 readings are there. Summation of the 10 reading divided by 10, you will get average rebound number 40.2. So approximately equal to, that it will be 40. We have to set the maximum limit. Apart from 40, how many readings are there? That is 4. That is maximum limit, that is 40 plus 4, that is 44. And minimum limit 40 minus 4, that is 36. Now we have to find out the average modified rebound index. So in this reading which will not come in between upper limit and lower limit, that we have to discard. So no values are there. So your average modified will be same, that is 40, and we have to find the compressive strength by correlating the rebound number with the compressive strength. From the graph, the value of compressive strength will be 49 Newton per mm square. So we can conclude that the concrete layer is hard and that is very good layer. So today we have seen how to perform the rebound hammer test. In this we have studied the use of rebound hammer and how to calculate the rebound number, that is rebound index, and how to correlate this rebound number, rebound index with compressive strength of concrete that we have seen. That is also, that is how the rebound index and rebound number is having correlation with the hardness of concrete. This we have studied. And as the rebound number increases, rebound index increases, the hardness will also increase. So I am appealing that watch both the parts of rebound hammer test. Thank you.